Thought I might have a look at these today. So I bought a couple of battery testers. So this one here's got the conventional analog sort of meter readout, and then this one's got some kind of LCD. So I've never used these ones before, but I thought it would be interesting to have a look, take them apart, see what kind of electronics are inside them. So there's a caliper here that you can adjust for the size of your battery. And there's also a couple of terminals here, I presume to put a, one of these 9-volt type batteries on the end here. Oh, there we go. So that bounces right up to good there. It's actually hitting the end stop so hard I can hear it. So that's the AA battery, AAA. Oh, that one doesn't seem so good. Replace, that says. Perhaps I should fire up the multimeter as well. So yeah, that's less than 1 volt, so I would think of that as being a replace. Let's have a look at this other one. This one's reading 1.6, so that's obviously pretty fresh, that battery. And oh yeah, forgot a Duracell 9-volt battery here. Well, that reads as good as well. Let's double check that. That says 9.6 volts. Again, a very fresh new battery, that one. So there's a couple of little screws in there, little posi drive. So let's open it up and have a look. Right, so you see inside here there's really nothing but the meter and a few wires. So there's a little tiny circuit board on the back here. I can see some surface mount resistors, but then that's basically just soldered directly onto the this moving coil gauge. So let me just figure out what how those resistors are connected. I can draw a little circuit diagram. So this is what we find in here. So there were 4 surface mount resistors and they got the values marked on them. So 221 means The final one means you add a single 10, so that's 220 ohms. 3R9 means 3.9 ohms. 362 is 3600, so 3.6 kilo ohms if you like, and 561 will be 560 ohms. So then if you kind of buzz it out, what you see is on the 1.5 volt side we've got the red, the clamp, and the black connector, which is the negative. So we've got the 3.9 ohm resistor is basically a load, so that a load of current is going to flow to ground through the 3.9 ohm resistor, so that puts the battery under load. And then we've got a series resistor in series with that moving coil meter, which is going to reduce the current. And basically I haven't measured the meter, but there'll be some internal resistance in here, and what they're trying to do here is make the resistor and the voltmeter into a voltage divider, so that we get the full scale deflection of the meter when it's at, you know, something like 1.6 volts, which is what a fresh battery would be. And then a similar thing on the 9 volt side. So on the 9 volt side you've got the red connector here, or it's not marked in red, but you've got a plus and a minus on the top here, and actually this one here, the minus, is the same piece of metal, so sort of cheapest possible design. So again we have the 220 ohms is the load resistor, so some load is being put across the battery, and then the series resistor is predictably a bit bigger than on this side because there's a bigger voltage is going to be put across the meter. And for clarity, that this point and this point are the same, this point and this point are the same, so it is actually, you know, on the one circuit board we've got these resistors are actually connected to each other. But of course the idea is that you'll only ever have either a 9 volt battery or a 1.5 volt battery plugged in at any one time. So you know, very, very simple design, and it does have the benefit of actually loading the battery through these load resistors, so you get something more of a realistic reading because the battery is providing some current. So this one's reassembled now. Time to crack open the second one. So this one is a digital one, so if I put the battery across here, you see it says 1.56 volts. This is a fresh new battery. So you see the philosophy is a bit different on this digital version. So instead of having, you know, sort of good, bad, you know, marginal indication, it actually gives you the voltage, so it reads out a voltage. So this is just a simple voltmeter. It's exactly the same case with the screw holes in the same place. And here we go. So in contrast, this has got quite a bit more electronics inside it. So I can see that looks like an inductor there. So there's an inductor and a couple of capacitors, and this, it looks like a transistor, but it could have 4 terminals on it. The diode will be here to stop you from accidentally putting a reverse voltage across this, because there's a chip here which presumably could get damaged by that. And then on the 1.5 volt side here, again we've got a little diode here. That's like a little silicon signal diode. That looks like it might be a regulator, maybe a small regulator here to bring the voltage down to a lower level. And then these pins here, I think this is the pins of the display underneath. So this is how the LCD display is connected to the board. Just take these screws out. Oh no, I see. So there's like a zebra strip here. So it uses the pressure of the board on there to connect it to the display. So these are the pins for various pins to drive the display, and it's pushed down onto this zebra strip, and that makes an electrical contact. So, and there's nothing else on the back of the board. So so this chip here is not marked. It looks like it's been scraped to get markings off it, but it does say something in here. It says TLX02, so we can have a look for that, see if we can find any matching chip. But it's quite likely that it's just LCD driver chip, and it's got some kind of voltage sensing in it. Now on this side you need a regulator to bring down the 9 volts to a lower level, because this will probably be a 3 volt or a 5 volt chip. On this side you've got the opposite problem, because 1.5 volts is not going to be enough to drive a chip like this, or to drive the display. So I think this is probably a booster chip, and I don't know what this says on it. It does have some markings, E3OJ. So I can look for that on the internet and see if I can find a booster chip that in that package that uses this kind of circuitry with the capacitors and the inductor. Let's have a look at that. Well, I couldn't find exactly that chip, but this looks very like a similar sort of thing. So here we've got, again, this comes in 2 different packages. So I think we've got what have we got here? This is kind of this one here, the SOT89. So it's a SOT89 package. The circuit diagram here shows a SOT25, but you can see the principle is the same. So you have a chip, there's an inductor here, there's a capacitor on this side, there's another capacitor, tantalum capacitor on pin 2, and this here is a Schottky diode. So I guess on here that surface mount diode, which is marked SS14, will be a Schottky diode. So this allows you to input a low voltage and boost it up to a useful higher voltage. So in this case the input range is from 0.9 volts, and then the output can be anything up to 7 volts depending on the circuitry that you use. So I think that's what's happening in this meter. It's got a similar sort of circuit to that. So this is obviously much more expensive component count on this one. The digital version. I actually quite like the analog style you know, which gives you a sort of general indication of the battery quality rather than an exact voltage. Because, you know, if you display an exact voltage, then that's kind of implying that you know what a marginal battery voltage is. I'm not sure that everyone does. Right, let's just check that that's working again. Now I've screwed that back together. So there you go, the display is working again. That's reading 1.58 volts. And that's that really. Very simple circuitry, which is why they can build them to such a low price really. I think both of these were under £1 for the unit itself. I mean, now after the pandemic, a lot of the delivery charges seem to be a lot higher, so the charges were higher for this. But there we are, two cheap battery meters, BT-168 and BT-168D, and the internals, how they work.